National Electrical Code Article 110.21 addresses the identification and marking of electrical equipment. This is crucial for safety, especially when dealing with systems like a three-phase 240-volt system with a high leg, sometimes referred to as a stinger leg or wild leg. Let's break down the location and marking requirements according to the NEC. Regarding location, the code differentiates between exposed to view and enclosed equipment. Firstly, equipment exposed to view must be in plain sight and not readily accessible to unqualified personnel. This means the high leg conductor and associated equipment should be easily visible for inspection and maintenance but protected from accidental contact by unauthorized individuals. Secondly, if the equipment is enclosed, it needs to be in an enclosure designed to prevent accidental contact. This enclosure must be robust enough to withstand the environmental conditions of the location and prevent unintended access to the energized components. Now let's address the marking requirements for a high leg. The NEC mandates clear and permanent identification of the high leg conductor and associated equipment. This includes several methods of marking. Firstly, the conductor must be permanently marked with the words high leg or 240 volts in letters at least 1/2 inch high. This marking should be placed at regular intervals along the conductor and at each termination point to ensure clear identification throughout the system. Secondly, orange paint can be used to provide additional visual identification. 2 orange stripes, each not less than 1 inch wide, should be painted on the edge of the panel or enclosure containing the high leg conductor. This orange marking serves as a visual warning to electricians and other qualified personnel of the presence of a high leg. Thirdly, a caution label approved for the purpose can be used as an alternative or supplement to the other marking methods. This label should clearly state caution high leg or a similar warning message and provide information about the voltage and potential hazards. It is critical to use labels that are specifically designed for electrical applications and are resistant to fading, chemicals, and other environmental factors. Here are some additional points to consider about high leg systems. A high leg delta system typically has one phase winding center tapped, with that center tap connected to ground. The voltage from the center tap to either of the other two phases, which are the A and C phases, is 120 volts. However, the voltage from the center tap to the remaining B phase, the high leg, is approximately 208 volts. This higher voltage can be dangerous if not properly identified and handled. Due to this difference in voltage, it's essential to accurately identify the high leg during installation, maintenance, and troubleshooting. The NEC requires that the high leg be identified at every point where connections are made, including panel boards, disconnects, and other equipment. It is also important to understand the implications of a high leg system for equipment connections. Single-phase loads should never be connected between the high leg and neutral, as this will result in a voltage that exceeds the rating of most 120 volts equipment. Instead, single-phase loads should be connected between the A or C phase and neutral, where the voltage is 120 volts. Three-phase loads can be connected to all three phases, including the high leg, but it is essential to ensure that the equipment is rated for 240 volts and is compatible with the high leg system. The NEC also addresses the use of overcurrent protection devices in high leg systems. It is important to select overcurrent protection devices that are properly rated for the voltage and current of the system and that are installed in accordance with the code. Circuit breakers and fuses should be sized to protect the conductors and equipment from overload and short-circuit conditions. Regularly inspect and maintain electrical systems, including high leg systems, to ensure that all components are in good working order and that all markings are clear and legible. This includes checking for signs of damage, corrosion, or overheating and replacing any defective components as needed. Periodic testing should also be performed to verify the integrity of the grounding system and to ensure that the high leg is properly identified. Safety is paramount when working with electrical systems, especially high leg systems. Always follow safe work practices and use appropriate personal protective equipment such as gloves, safety glasses, and insulated tools. Never work on energized equipment unless you are qualified and authorized to do so, and always de-energize and lock out the circuit before performing any maintenance or repairs. The NEC requirements for marking and locating the high leg are designed to prevent accidental contact with the higher voltage conductor and to ensure that qualified personnel can safely work on the system. By following these requirements, you can help to reduce the risk of electrical shock and other hazards. In addition to the NEC requirements, there may be local codes and regulations that apply to high leg systems. It is important to consult with your local electrical inspector or building department to ensure that you are in compliance with all applicable requirements. Some jurisdictions may have additional requirements for marking, location, or grounding of high leg systems. These requirements may be more stringent than the NEC requirements and must be followed to ensure compliance. It is important to note that the NEC is a minimum standard and that it is the responsibility of the electrician or electrical contractor to ensure that the installation meets all applicable requirements. The NEC does not provide a complete set of instructions for every situation, and it is often necessary to exercise professional judgment and experience to ensure that the installation is safe and compliant. In some cases, it may be necessary to consult with a qualified electrical engineer to determine the best way to install a high leg system. An electrical engineer can provide guidance on the design, installation, and maintenance of the system and can help to ensure that it meets all applicable requirements. In conclusion, understanding and adhering to NEC Article 110.21, along with local codes, is crucial for safety when working with three-phase 240-volt systems that have a high leg. Proper marking and location, using orange paint, permanent labels, and appropriate enclosures are essential for protecting personnel from electrical hazards. Regularly inspect your systems and prioritize safety by following all codes and regulations. These practices are essential for preventing accidents and ensuring a safe working environment. The specific requirements outlined in the NEC, such as using letters at least 1/2 inch high for markings and ensuring enclosures prevent accidental contact, are not arbitrary. They are based on years of experience and analysis of electrical accidents. Adhering to these standards minimizes risk. The high leg system, while providing flexibility for both single-phase and three-phase loads, introduces the complication of the 208 volts leg. This voltage can be destructive to equipment designed for 120 volts, hence the critical importance of clear and unambiguous identification. Proper training is also key. Electricians and maintenance personnel must be thoroughly trained on the characteristics of high leg systems and the proper procedures for working on them. This training should include instruction on how to identify the high leg, how to connect loads to the system, and how to troubleshoot problems. Training should also emphasize the importance of following safe work practices and using appropriate personal protective equipment. Over time, markings can fade, labels can peel, and paint can chip. Regular inspections are vital to ensure the continued effectiveness of the identification system. These inspections should be documented, and any deficiencies should be corrected promptly. It is also important to keep up to date with the latest revisions of the NEC and any applicable local codes. Electrical codes are constantly evolving to reflect new technologies and best practices. By staying informed about the latest code requirements, you can ensure that your high leg system is safe and compliant. The grounding of a high leg system is another critical aspect of safety. The grounded conductor, typically the neutral, provides a return path for fault currents and helps to protect against electrical shock. The grounding system must be properly installed and maintained to ensure its effectiveness. The NEC provides detailed requirements for grounding electrical systems, including high leg systems. These requirements cover the size and type of grounding conductors, the methods of connecting to ground, and the testing of the grounding system. Failure to properly ground a high leg system can result in dangerous voltage levels on equipment and an increased risk of electrical shock. In addition to the NEC requirements, there are other industry standards and best practices that can be used to improve the safety of high leg systems. For example, the National Electrical Manufacturers Association, or NEMA, publishes standards for electrical enclosures and other equipment. These standards provide guidance on the design and construction of equipment that is safe and reliable. There are also a number of organizations that offer training and certification programs for electricians and other electrical workers. These programs can help to ensure that workers have the knowledge and skills necessary to safely work on high-leg systems. Furthermore, consider the ambient conditions where the electrical equipment is installed. High temperatures, humidity, and corrosive environments can all degrade the insulation and other components of the system. It is important to select equipment that is rated for the specific environmental conditions of the installation and to take steps to protect the equipment from the elements. This may include using weatherproof enclosures, corrosion-resistant materials, and regular cleaning and maintenance. The information provided is for general guidance only and should not be considered a substitute for professional electrical advice. Always consult with a qualified electrician or electrical engineer before working on any electrical system. Electricity can be dangerous, and it is important to take all necessary precautions to protect yourself and others from harm. By following the NEC requirements, local codes, and industry best practices, you can help to ensure that your high-leg system is safe and compliant. Remember that safety is always the top priority when working with electricity. Always take the time to do the job right and never cut corners. The life you save may be your own.